Hello, that was a really good welcome. Thank you. I have to say I've been really really impressed with all the speakers today. I feel like I've learned a lot at this conference. So thank you, Matt and Daniel, for organizing it, because it's one of the better conferences I've been to. Okay, so today I'm going to be talking about how views are created and updated within frameworks. But first, I'll tell you a little about myself. My name is Chaela Womack, and I'm a UI engineer at Netflix. I work within the studio organization at Netflix. So what that means is I get to work on really cool apps that make it easier for us to make new Netflix originals like Stranger Things. So in my time at Netflix, I've worked in an Ember app and a React app. And before I came to Netflix, I primarily worked in Angular. I did a little Angular JS, and I even worked in an in-house framework that was like a Frankenstein of different libraries. So all of this is to say I've developed framework fatigue. I've worked in 5 different frameworks in 3 years. And most of us as developers will have to work within multiple frameworks in our career. So learning a new framework is a lot of work. On top of learning the framework, there's usually a new set of tools and libraries to come along with it. And then you still have to learn your application logic and business domain on top of that. So the way I typically approach it is I'd learn the basics and the syntax, and then I'd focus on the small level of building a good component. But I started to think about my future self. What were the frameworks that I was going to need to learn in the future? What if I didn't even need a framework at all? So this had me a little concerned. As engineers, we're always focused on solutions. The applications we build are solutions to problems. But if we focus too much on the solution instead of the problem, then it can hinder our ability to evolve and innovate. So that's the situation I felt like I had gotten into. My experience had always included using a framework. And so I felt like I had a gap in my knowledge about the problems that frameworks were specifically using. Why was I using a framework at all? At the heart of all the views I end up building are the DOM and the browser. That's what the user is actually interacting with. So when my code actually reaches the DOM in the browser, I wasn't quite sure what was happening, because frameworks are really taking care of this for us. So I started on this journey of finding the common patterns used amongst frameworks. So if you start looking at all the frameworks, it can get overwhelming because all you see are the differences. But one of the ways to avoid that is to look at things from a high level so that you can actually see what is similar between them. So frameworks offer many solutions to many different problems, but today I'm only going to be discussing how we use them for creating views. But I think the best place to start for this is to understand the problem that frameworks are actually solving for. And this will make it easier for us to understand the solutions that they provide. So let's get started with that. As I started researching, it really coalesced around these 3 areas of the DOM API, DOM manipulation, and keeping the application state in sync with the DOM. So if you decide not to use a framework, you're going to run into some issues with these areas. So let's start with the DOM API. The DOM API is a set of methods exposed over the browser that let us interact with and traverse the DOM. So think of things like document.querySelector that let us query the DOM tree for a specific node. Under the hood, our frameworks are using the DOM API in some form. But if you decide to use it as a developer, you're going to run into a couple of issues. So I learned best by example, so I think it's easier to understand this by seeing one. So here I have a simple list, and we're just adding a new item into a list. It's a very trivial functionality. And I wrote how we could do this with the DOM API. So to briefly describe this, we're first going to query the DOM for the input, because we want to know what the user entered. And then we're going to create a new list element and set the text content on that item. And then finally, we have to query the DOM again so that we can get the actual parent list to add that new node we created. So it takes a lot of code to accomplish this. So some of the problems with this are that using the DOM API to create dynamic elements is very verbose. When you have verbose code, it's not very readable. So this can be hard on a developer. Another issue is that we had to query the DOM twice to know about the input and to know about the parent list. And relying on selectors is inherently brittle. So for example, we change our HTML and change the class names, and then we don't update in our JavaScript, our application is completely broken. So this is hard to scale, especially as complexity or team size increases. Another issue with JavaScript and the DOM API is that every browser has their own implementation. So while it's mostly similar, there can be nuances and differences between them. A library like jQuery handles this for us so that we don't have to worry about the cross-compatibility issues. But if we're not using a library, we need to make sure that our code functions the same in every browser. And then the final issue with my example is that we don't have a good separation of concerns. In software, we typically want to have a separation of functionality because it's easier to maintain. But with this, our logic for updating the view is tangled in with the application logic. So again, this creates issues as we add complexity. So now let's talk about DOM manipulation. DOM manipulation is anytime we update the DOM tree. So it might be adding a class to an item, or it might be like our other example where we're just adding an item into the tree or removing something from the DOM tree. DOM manipulation is actually really important because it's how we create interactive websites for our users to actually interact with. The problem with DOM manipulation is that it is inherently expensive. And what I mean by that is that there are significant performance costs to performing DOM manipulation. So if we think about this, it comes back to the fact that the browser is a system like any other. It has memory and performance constraints. And if we bring it all the way back to our user, the device that they're serving the browser and our application on is going to be limited based on whatever resources they have available on that device. So we need to remember this as we're creating DOM nodes, because every DOM node we create has a cost. One will be pretty cheap, but if we have a DOM tree of 1,000 elements, this will quickly add up in memory, and this could slow down our user's experience. And it's actually a lot easier to create a tree of 1,000 elements than you would think, because oftentimes we're using these additional divs for layouts and styling. So we just need to remember that not all of our users have the most fancy device and the latest hardware. And so that pretty layout we're creating could have some negative effects in the long run. A bigger issue with DOM manipulation, though, is from something called repaint and reflow. So repaint and reflow are these complex calculations that the browser performs to determine the layout and styling of elements on screen. So here I have an example of the Google homepage going through a repaint and reflow. And there's a lot of work going into determining that layout. And the Google homepage is very simple. There's only a few items on screen. So if we imagine for some of our more complex applications that have a lot of elements on screen, this could take even longer for the browser to perform these calculations. The problem is that when the browser is going through a repaint and reflow, it's actually a blocking action. Users can't interact with our site. So as we're updating the DOM, we're potentially blocking the user from doing anything with our site. So DOM manipulation is important because it allows our users to interact, but if we're not mindful about the performance impacts, they might not want to use our site at all. So the next issue I'm going to talk about is not an issue with the DOM API or the browser, but it's actually an issue of application state. We'll typically have some internal state in our application, and the DOM becomes the visual representation of that. So as our internal state changes, we want to keep the DOM in sync with that internal state. So how can we do that if we don't use a framework? So let's look at our example from earlier, where we have a list of items. But this time, the list is going to be really big. It'll have hundreds of elements in it. And we want to update specific items in that list. So how could we go about that? The easiest way as a developer to do this would just be to recreate the whole list. So the problem with this is it's not ideal for our users. If they're interacting with the list and then we stop them to refresh the whole page or refresh the whole list, that's not going to make them very happy, especially if they lose the work that they're doing. And now we know about the issues with performance, that creating DOM nodes is expensive and performing a large repaint and reflow is expensive. So this could take some time to recreate the list. So I think we can do better than this. So as developers, another way we could do this would be to only update the specific items in the list that are needed. So how could we go about this? If we have our new list, we could compare it to our current list, figure out what's different between them, and then we need to know how those are referenced on the specific DOM elements. And once we have that figured out, we can perform a DOM update. So as you can imagine, doing this would be quite cumbersome. We'd much rather focus on our business logic instead of writing these generic solutions that have to be rebuilt every time. So this is part of the reason frameworks have become so popular. They give us solutions like this out of the box, so we can focus on writing unique solutions to problems that our users don't have yet. So now we've covered some of the problems that we'd run into if we decide to not use a framework. I'm going to cover some of the common patterns that frameworks use to solve these problems, and then I'll go into some implementation details about some popular frameworks. So let's start with templates. Templates let us create dynamic DOM elements without having to use the DOM API. So it's really nice. It usually takes form with a component, which will probably be a class, and it'll have properties in it. And then we can use these properties as dynamic pieces in HTML. So using a template solves a lot of the issues that we ran into earlier with using the DOM API. We get semantic code with this template. This is a handlebars template, but it looks actually very similar to what will be created in HTML. So readability and writability goes way up by using a template. Another benefit is we no longer have to rely on those selectors to update the list. We only need to manage the state on that property within our component. So that's another benefit of more maintainability. And then finally, we get a good separation of concerns when we use templates, because the logic for creating and updating views will always live in the template. So even if our template lives in the same file as our component, there will be a distinct separation between the template for the view logic and the actual component logic. So it's really nice. So here I have an Angular and a JSX template. Most template engines take an approach like Angular, and they bring JavaScript into HTML. So this might be a really good way for somebody comfortable with HTML to start programming, because it can feel less intimidating than diving right into JavaScript. JSX, on the other hand, takes the inverse approach. It brings HTML into your JavaScript file. So your template and component are living in the same file. And this really favors the JavaScript developer. You don't have to learn a new syntax. You just write JavaScript in between two curly braces. So your view logic and component logic can be seen at the same time. And there are some benefits to that. Ultimately, templates are this generic pattern that have a lot of similarities. So typically, once you learn how one template works, it becomes really easy to move between them. And they're used in pretty much all front-end frameworks. So when we create these templates, we can't pass them directly to the browser. The browser wouldn't be able to do anything with them. So they have to go through some processing. So our frameworks will parse our templates. They need to pull out the HTML and also evaluate the dynamic pieces that we put in there. So they'll evaluate the dynamic pieces and compute those expressions so that they can become actual values. And then before it can become DOM elements, our framework is going to store those dynamic values, the actual current state of them, in some JavaScript form. So this is a pretty high-level overview of how frameworks handle it, and there's a lot of different implementation details between them, but in a generic form, this is what they're doing. So ultimately, frameworks are a really good solution, templates are a really good solution, and they're much better than using the DOM API. So now let's talk about how we can keep our DOM in sync with our application state as it changes. If you go and research all the different frameworks, you'll find a lot of different implementation details about the specific frameworks, and it becomes hard to find the similarities between them. But if you look from 5,000 feet, you'll see that it really just relies upon a trigger and a comparison strategy. So let's talk about the trigger first. The trigger is the thing that's going to start off the whole process. It's going to notify our framework that a DOM update needs to happen. So it's some action within our framework or within our application that will tell the framework to run the comparison strategy afterwards. The trigger is the high-level pattern, but it can be taken in many different ways. So I'm going to talk about 3 specific ways that popular frameworks handle it. So let's start with the internal function. The internal function is just a function provided by the framework. And when you call it as a developer, it tells the framework to perform a DOM update. So I think React is a really good example of this. It has a function called setState, and it manages the internal state of your component. But it also tells React that a DOM update needs to occur. So this is really nice and easy to understand as a developer. But it can also take form in other ways. Angular provides a function that when you import it, its only utility is to kick off change detection. With either approach, it really puts the power in the hands of the developer to determine when these DOM updates should occur. So another trigger we could use is to patch the browser. Monkey patching is the act of extending or modifying the original API. So in this case, we'd be modifying the browser API. So I have an example of a simple monkey patch on the setTimeout function. And this is actually a little bit more complicated because setTimeout is an async event. So our callback is going to run at a later time. So let's briefly talk through this code. I first need to assign or grab a reference to the original setTimeout because I want my developer to think nothing has changed. I then override whatever the original function was on the window. So when a developer calls the setTimeout function, I'm going to take the callback that they passed in, and I'm going to patch that because I want to notify my framework after the callback is executed. And if I were to not patch this callback, then I could potentially notify my framework before the callback ever runs. So after I patch the callback, I call the original setTimeout with those arguments and my patched callback. So this concept is actually what Angular chooses to do as a trigger. It uses a library called Zone.js, and it patches all the async events in the browser. So after an async event is done executing, it will notify Angular that a DOM update probably needs to happen. So this kind of takes an opposite approach of the internal function. This is completely tucked away from the developer. As a developer, you don't even need to know that this is how Angular is updating the views, because you can still write all of your application logic without having any knowledge of this. Okay, so the final trigger I'm going to talk about are changes to component properties. A framework, in this case, would watch the properties within a component. And when they change value, it would then decide to perform the DOM updates. So we can go with 2 different approaches with this. We can watch all the properties within our components. But oftentimes, we'll have properties that actually don't need to change at all and aren't necessary for the template or the DOM updates. So in this case, we probably only want to watch specific properties within our component. And so this is the approach Glimmer takes. It provides an annotation, and you as a developer set that annotation on the properties that you want to trigger DOM updates. So here in this example, I have a tracked annotation on title. And if I reassigned a value to title, I would then see it reflected in the DOM. But let's say I removed that annotation and made the update, I would no longer see those changes reflected in the DOM. So an approach like this really puts the onus on the developer because they're probably the most knowledgeable person about what should be static and dynamic over time. So now we've covered some triggers and we have a good understanding of what they do. They tell our framework to perform a DOM update. But as you can imagine, sometimes this trigger is going to fire off and a DOM update doesn't need to happen. We know that DOM manipulation is expensive, so we're potentially performing these expensive updates when they might not be needed at all. So this is where frameworks come in and try to solve that issue. When we last rendered our template and we have those dynamic values, we're storing them internally in some current state that the framework is holding. Well, when that trigger fires off again, then we're going to compute those new values and compare them to the previous ones. If there's no change, then we've saved ourselves a costly DOM update. Let's say something has changed. Then we'll store the new values and perform a DOM update. So this comparison strategy that frameworks are using is really important because this is how we optimize for DOM updates. So I'm going to talk about 2 ways that we can handle this. Let's say you decided to use your own framework or build your own framework. You could use either of these strategies because they're framework agnostic. And that's why I think it's good to understand what our potential options are. So let's first talk about the virtual DOM. The virtual DOM decides to take an approach of creating the DOM tree, but a JavaScript version of the DOM tree. So this will be objects in a tree data structure. My list from earlier, I have an example here of what it would be in virtual DOM. And as a JavaScript developer, it's pretty easy to see how this could then be mapped to DOM elements. So when we use a virtual DOM, our framework is storing that virtual tree at all times. When the trigger fires off, it's going to create a whole new tree and compare it to the one it's currently storing. It'll figure out the differences between the 2 trees and then perform a DOM update if it's needed. So this is a really fast solution to performing DOM updates, but there is a caveat. There's always a trade-off. So the issue with this is that we're having to store that virtual tree at all times. And we know this is taking memory from our user's device. So if we have a large DOM tree, this might be a costly thing to store. So there are 2 ways that we could try to make the there's 2 ways to do the virtual tree. One is just create the whole tree, static and dynamic content. Another approach, which tries to optimize for that issue of storing a large DOM tree, is to only store a tree of dynamic elements. So this is the approach Glimmer does, and it's able to do this because it has those tracked properties that you're saying are only important for DOM updates. So this can drastically cut down the size of the tree, especially if you know you're going to have a lot of static content. So Glimmer might be a better approach if you do have a lot of static content. So now let's talk about the incremental DOM. This is a strategy that was developed by Google, and Angular has recently released a new engine called Ivy that takes advantage of this approach. Incremental DOM is really meant to be used as a compilation target for template systems. So here we have the incremental DOM API uses functions for creating DOM elements. So in this case, if we had a template using incremental DOM, it would then be compiled into something that looks like this. So incremental DOM takes the approach where when an update needs to happen, it will create a virtual tree, like virtual DOM, but instead of creating another virtual tree, it'll take each node in that virtual tree and compare them one by one to the actual DOM. So this cuts down on the memory size that we have to use when we're using virtual DOM. And this is where incremental DOM can really be a better option if we're concerned about memory size. So while it might not be as fast as updating when it comes to virtual DOM, you might win in other performance areas. So considering who your user is, this might be a better option. Ultimately, incremental DOM and Virtual DOM are taking very similar strategies. They're using JavaScript to create DOM elements and using some equality check to determine when those DOM updates should actually happen. So now we've covered 3 issues and 3 solutions. Templates let us create dynamic DOM elements, and then we rely on a trigger to determine when those elements should be updated. And then we use a comparison strategy to make sure that we're only updating the elements that we actually need. So if we think about this, this is a life cycle of the view. It gets created, checked, and updated. And we want our frameworks to handle that for us. But sometimes we need to hook into those events. And frameworks give us the option to do this by providing component lifecycle hooks. This allows us to write specific functionality that we might need or provide optimizations with performance, but we still don't have to handle the rest of the cumbersome logic. So this is a great way that frameworks try to help us and give us flexibility. Ultimately, frameworks are just bridging the gap between us and the browser. Browsers are continuing to evolve, so maybe in the distant future, we don't need frameworks at all. But frameworks are there for developer experience, and they make it a lot easier to build applications. I hoped some of this has sparked your curiosity. This was a pretty high-level view, but there's a lot of depth in each of these topics. We can build applications without using a framework at all, but they make it easier. But I would encourage you to not be afraid to write your own solutions, because sometimes the solutions that you will write will be better than the solutions that the frameworks actually provide for you. So I don't want you to feel tethered to a framework for your development experience, because ultimately, if you feel like you are knowledgeable enough to work without them, then when you do choose a framework, you know you've chosen the right framework for your right problem. Thank you.